Imagine yourself seated by a window on a clear night, gazing upward at a sky filled with twinkling stars, pondering whether someone far away might be looking back at us. This is not merely a fanciful notion but a question that has troubled millions of people across countless generations. In the realm of modern science, the idea of an extraterrestrial invasion is frequently depicted as disc-shaped flying objects hovering in the heavens, emitting dazzling beams of light, or as colossal spacecraft that eclipse the sun itself. Yet, if a civilization far more advanced than our own truly exists, one that transcends our wildest imaginings, they would have no need for such rudimentary methods. They could command the very fundamental laws of the universe, altering the fabric of reality with a mere touch upon its underlying code. This is the manner in which scientists infer the highest tiers of civilizations through a classification system known as the Kardashev Scale. This scale categorizes societies based upon the quantity of energy they can harness, reminding us that humanity remains in its nascent stages, with numerous challenges and thorny paths lying ahead. Let us journey back in time to the year 1964. In Moscow, the Soviet astrophysicist Nikolai Kardashev sat in his laboratory, brimming with passion for exploring the boundless cosmos. He proposed a simple yet profoundly influential idea: to classify civilizations according to the amount of energy they could utilize. Initially, this began with 3 primary levels, but later, eminent physicists such as Michio Kaku, who is renowned for his ability to explain complex scientific concepts in an approachable manner, along with others, extended it to 7 levels through logical deductions grounded in physics and astronomy. Each level does not merely represent a linear increase in energy, rather, it signifies an exponential leap, approximately 10,000 times greater than the previous one. This is akin not to the gradual stacking of floors in a towering building but to the explosive detonation of a bomb, unleashing entirely new possibilities in a burst of transformation. According to calculations by scientists like Michio Kaku, humanity currently lingers at approximately 0.73 on this scale, meaning we have not yet attained even the first level. This fact diminishes our sense of grandeur. Our achievements, such as vast nuclear power plants or endless fields of solar panels stretching beneath the sun, might appear to a more advanced civilization as primitive as a caveman rubbing 2 sticks together to produce a feeble spark, accompanied by crackling sounds and acrid smoke. As of 2025, estimates place Earth civilization's energy consumption at around 25 terawatts, corresponding to this 0.73 rating. This represents a slight increase from the 0.7276 figure in 2023, with projections suggesting it may reach 0.7449 by the year 2060. Recent studies, including those published in scientific journals up to 2025, reinforce this assessment, noting that while renewable energy adoption and technological efficiencies have driven this modest rise, profound systemic changes, such as global fusion power integration or orbital solar farms, would be required to accelerate our progress significantly. However, the most disconcerting aspect is not our present position but the perilous journey ahead, fraught with lethal pitfalls. Consider the Fermi Paradox, posed in 1950 by the physicist Enrico Fermi during an ordinary luncheon with colleagues at the Los Alamos laboratory. He glanced at the vast sky, pointing to the billions of stars glittering like grains of sand on a beach, and inquired, if the universe is so immense, why do we not hear the voices of other civilizations? This moment plunged everyone into silence, stirring deep fears about humanity's profound isolation. One explanation for this paradox is the Great Filter Theory, proposed by the economist Robin Hanson in 1996. This theory posits that most civilizations perish during the transition from approximately 0.7 to the first level, much like a ship navigating a sea riddled with reefs and storms. Potential threats include nuclear warfare, which could unleash thunderous roars and black mushroom clouds shrouding the heavens, climate collapse, where rivers run dry and verdant forests transform into dust-swept deserts, or uncontrollable artificial intelligence, awakening like a colossal machine to devour its creators. Even an asteroid hurtling across the cosmos at tremendous speeds could end everything in an instant. Statisticians, employing intricate mathematical models, estimate the probability of surviving this stage at less than 1%. Our future boils down to 2 stark choices: ascending to a higher civilization amid cheers of triumph and the conquest of the cosmos, or flickering out like a candle in the cold darkness, silenced forever. Among the latest theories in 2025, some suggest that the Great Filter is not a single monumental barrier but a sequence of smaller obstacles, such as the emergence of life itself, the development of intelligence, and subsequent technological advancements, each progressively reducing the odds. Another hypothesis, known as the grabby aliens theory, proposes that already expansive civilizations preemptively hinder the rise of others. Additionally, the dark forest hypothesis, inspired by the Chinese novel The Three-Body Problem, envisions the universe as a shadowy woodland teeming with hunters, where those who make the loudest noise are the first to perish. These diverse conjectures continue to vie in explaining the Fermi Paradox, with ongoing debates in astrophysical conferences emphasizing how artificial intelligence might itself represent a pivotal filter, potentially leading to self-destruction if not managed with utmost caution. If we are fortunate enough to pass through this great filter, humanity would undergo a true metamorphosis, akin to a larva transforming into a freely soaring butterfly. A Type 1 civilization would fully command all energy available on its home planet, amounting to approximately 10 to the power of 16 watts, an astonishing figure that leaves one speechless. For comparison, humanity's total energy consumption in 2023 was about 18 terawatt-hours annually, whereas a Type 1 level demands 10,000 terawatt-hours, roughly 50,000 times more. Scientists predict that achieving this would require at least another 200 years, but envision the spectacle, Earth evolving into a colossal smart city, where howling storms accompanied by thunderous roars are quelled as easily as extinguishing a bedside lamp. Gigantic mirrors orbiting the planet would regulate sunlight, converting arid deserts into oases resonant with the sounds of flowing water and the scents of blooming flowers. Earthquakes would be foreseen and their pressures released, transmuted into clean energy that flows into a worldwide grid. Nature would no longer be an adversary, sweeping away everything in floods or cracking the ground in droughts, but a precise instrument serving human life. More crucially, Type 1 status implies global unification. Borders riddled with barbed wire and gunfire would vanish, and wars over scarce resources would cease. Humanity would act as a single entity, gazing toward the cosmos with gleaming hope. This would enable the construction of permanent bases on the Moon, where one could hear the rhythm of one's own heartbeat in the profound stillness, or on Mars amid swirling red dust storms. Space elevators would become commonplace transport, whispering like a gentle breeze as they ferry passengers to orbit, and weekend holidays on Mars would become reality, with lighter gravity allowing higher leaps accompanied by peals of laughter. Yet all these wonders hinge upon surviving the Great Filter, filling hearts with anxiety and determination. Type 1 is merely the beginning, like a child taking its first steps. Once a civilization masters its planet, the next progression is to master its star. This is Type 2. They would require approximately 10 to the power of 26 watts, harnessing every ounce of energy emitted by their sun, about 3.8 multiplied by 10 to the power of 26 watts per second. Meeting humanity's current demands through conventional means would take 5 billion years, but a Type 2 civilization could accomplish it. In 1960, the American physicist Freeman Dyson unleashed his imagination and proposed the Dyson Sphere, a vast shell encasing a star to capture all its energy, like a gigantic orb enveloping a flame. Later, scientists recognized gravitational and material challenges might render a complete shell infeasible, leading to variants such as Dyson rings or Dyson swarms, structures resembling petals floating around a luminous core. In 2015, astronomers observed the star known as Tabby's star, or KIC 8462852, which irregularly dims by up to 22%, exciting many with the possibility of artificial constructs. However, according to NASA's latest research and scientific analyses up to 2025, this phenomenon is more likely attributable to uneven dust clouds or natural gas formations rather than evidence of an extraterrestrial civilization, though ongoing monitoring continues to rule out all alternatives definitively. Nonetheless, the concept evokes images of stars being swallowed by technology, with energy cascading in torrents. Recent studies suggest Dyson spheres could be stable in binary star systems, and applications might include digital immortality, such as resurrecting human consciousness. Furthermore, in 2025, 7 potential Dyson sphere candidates were identified through infrared surveys, though high-resolution imaging has revealed that some signals stem from natural sources like distant galaxies with black holes or M-dwarf stars with excess infrared emissions. 6 remain under scrutiny, fueling speculation and further observation. A Type 2 civilization could conceal itself, absorbing all visible light and emitting only warm infrared radiation, making detection arduous. The dark patches in our night sky might hide dozens of such civilizations, quietly observing us as we burn coal, belch black smoke, and clatter with machinery. Scarcity becomes obsolete. They could dismantle planets for materials, disassembling the swirling tempests of Jupiter to build Dyson structures. Matter and energy would interchange freely, enabling the creation of anything, and lifespans might extend to 200 years. Death would become a personal choice, accompanied by the melancholy of farewells. The original pinnacle envisioned by Kardashev, Type 3, represents the utmost limit humanity can conceive. They would harness the energy of an entire galaxy. Our Milky Way contains between 200 billion and 400 billion stars. Each enveloped in a Dyson sphere would yield 10 to the power of 36 watts, equivalent to 200 billion suns supplying power simultaneously. Energy would no longer pose a problem. They would investigate extreme phenomena like wormholes, as per Albert Einstein's general theory of relativity, tunnels connecting 2 points in space-time, permitting travel faster than light. Stabilizing a wormhole would necessitate energy equivalent to converting half a solar mass into pure energy, a feat Type 3 accomplishes with ease. They could breakfast in the gentle dawn on the galaxy's eastern edge, admire the blazing orange sunset in the west by afternoon, and return home for supper, traversing tens of thousands of light-years in minutes. Moreover, they would achieve consciousness immortality, bodies altered at will, minds uploaded, backed up, copied, or transferred as data. Death would be as light as the click of replacing a new hard drive. The concept of individuality might fade, merging into a collective intelligence spanning the galaxy, like rivers flowing into the ocean. Intriguingly, we might never detect a Type 3 civilization, not because they do not exist, but because they hide so adroitly. The apparent emptiness of the galaxy could stem from advanced life learning the art of silence. As in Liu Cixin's novel The Three-Body Problem, the universe operates under the dark forest rule, where the loudest are slain first. Scientists like Stephen Hawking have warned against contacting extraterrestrials, likening it to indigenous peoples encountering conquerors. Though Kardashev's original scale halted at Type 3, scientists, deeming it insufficiently thrilling, have appended for more levels based on contemporary physical theories. Type 4 would control the energy of the entire universe, or at least vast clusters of galaxies. They would exploit dark energy and dark matter, which comprise 95% of the cosmos, mysteries we still grope in the dark to understand. They could alter fundamental constants like the speed of light, the gravitational constant, or Planck's constant, parameters we deem immutable. Fancy reducing the speed of light from 300,000 km per second to 0? Adjust the dials, and all chemical reactions cease, stars whisper their last and extinguish, leaving you frozen in time without pain. More terrifyingly, according to physicist Alexander Vilenkin, our universe might be a bubble detached from a parent cosmos. Type 4 would dominate this, creating baby universes in laboratories. Our lives would resemble a sandbox game. Type 5 not only creates universes but traverses innumerable parallel universes per Hugh Everett's quantum mechanical many-worlds interpretation. Each quantum event branches the universe into multiple versions. Choosing a blue shirt in the morning spawns a parallel where you select red. They exist everywhere simultaneously, drawing energy from quasars, the brightest celestial objects, with central supermassive black holes shining as brightly as 1,000 galaxies. Constructing artificial quasars would be as routine to them as building power stations is to us. They attain true immortality. Death in one universe leaves consciousness surviving in myriad others, forming a network across the multiverse. Type 6 commands the rules themselves, rewriting physical laws like a programmer editing code. They impose new laws on chosen universes, existing as pure consciousness unbound by matter. Time, space, and dimensions become malleable clay. We might dwell within their creation, the universe their experimental box. Type 7 transcends civilization altogether. They are the universe itself or stand beyond all universes. Concepts of energy, matter, and space become meaningless. They are desireless and complete, having created everything, thus invading nothing. Universe creation is as simple as igniting a candle. They achieve absolute creation and infinite awareness, their purpose dreaming new realities into being. In 2003, the Oxford University philosopher Nick Bostrom proposed the simulation hypothesis. Sufficiently advanced civilizations could simulate universes on computers, making it probable we inhabit such a simulation. The odds of living in a base reality are far slimmer than in a simulated one. The words you read might be data, your joys and sorrows mere code executions. If they switch off the machine, 13.8 billion years of history vanish, countless lives erased without farewell. In 2025, Bostrom updated his frequently asked questions on the topic, maintaining a high probability, with some scientists estimating 70%. Counter-arguments exist, including a 2025 paper asserting the hypothesis is untestable or impossible due to computational limits, yet it remains a contentious and philosophically rich debate. So, to what level might humanity ascend? Scientists like Koku suggest Type 3 could be our limit, demanding shifts in consciousness, overcoming political divisions, cultural clashes, and environmental crises. We must learn cooperation over conquest. Perhaps we are the sole civilization, or the cosmos teems with silent ones. Or the universe is a grand simulation. Yet to comprehend our position, we must examine our larger home, the galaxy, which many fail to realize we inhabit. How can we know the whole structure from within? As the ancient proverb states, one in the mountains cannot perceive the true form of the mountain. Studying the Milky Way is a complex endeavor, the fruit of over a century of toil by premier scientists. In 1610, the Italian astronomer Galileo Galilei turned his handmade telescope skyward. With his beard and bright eyes, he beheld the faint silvery band as countless stars twinkling like diamond dust. Immanuel Kant, the German philosopher famed for profound contemplation, primarily delved into philosophy but boldly predicted the galaxy might be a rotating disk and that the universe harbors multiple such islands, astonishing his peers. Then came William Herschel, the British discoverer of Uranus, who, with his enormous homemade telescopes, divided the heavens into over 600 regions from dewy lawns late into the night, counting stars one by one. From this data, he drafted the first map of the galaxy, placing the Sun near the center, though unaware of interstellar dust-obscuring views. His map differs from today's, yet it proved the Milky Way a flattened disk of stellar clouds. In the early 20th century, the Dutch astronomer Jacobus Kapteyn, bespectacled and meticulous, measured star counts and brightnesses, concluding the galaxy was a disk with a diameter of 17 kiloparsecs and thickness of 3 kiloparsecs. In reality, influences from dark matter and dusty gases made it appear smaller. After Kapteyn's death, his student Jan Oort continued, discovering the Sun lies about 30,000 light-years from the center and orbits the galaxy in 200 million years, a timescale that induces vertigo when contemplating temporal vastness. Post-Second World War, Oort collaborated with Hendrik van der Hulst, utilizing the 21-centimeter wavelength radio emissions from neutral hydrogen, the universe's most abundant atom. This penetrates interstellar clouds impenetrable to visible light. At the 1952 Rome International Astronomical Union Conference, Oort presented the galaxy's spiral structure, the Perseus arm, the Orion arm, where the Sun resides, and the Sagittarius arm. The basic form was established amid applause from scientists. The 2000s brought further revelations. In 2004 and 2008, new spiral arms were confirmed, and the Milky Way was identified as a barred spiral galaxy, SP. Combining radio, infrared, and visible light data with simulations yielded today's detailed maps. According to NASA and ESA data up to 2025, the galaxy's diameter spans approximately 100,000 to 200,000 light-years, with 200 billion to 400 billion stars and a mass of 10 to the power of 12 solar masses. The center features a peanut-shaped bar region, 10,000 light-years wide, hosting 10 billion ancient stars. Spiral arms like Perseus and Norma extend outward, along with outer arms. In 2025, scientists discovered the Fermi bubbles, enormous structures rising from the center, extending on both sides of the galactic plane like an hourglass, possibly due to the supermassive black hole or stellar explosions. Additionally, the University of Geneva identified the most distant twin galaxy billions of light-years away, aiding structural comparisons. The Gaia telescope completed its Milky Way scan in 2025, mapping over 1.8 billion stars in 3 dimensions. Recent Gaia findings reveal colossal waves rippling through the galaxy, the largest 3-dimensional map of 44 million star-forming regions, chains of stellar gatherings stretching across the skies, and insights into the galaxy's history, including mergers with smaller galaxies that shaped its current form. Instruments like the James Webb Space Telescope promise to unravel even more secrets for future astronomers. The process of mapping the galaxy embodies humanity's scientific exploratory journey, replete with sweat, tears, and triumphant joy. Technologies such as the James Webb Space Telescope or ESA's Gaia mission will continue unveiling mysteries, deepening understanding. In this endless quest, humanity never halts. Ultimately, the Kardashev Scale teaches that civilizational evolution encompasses not only technological accumulation but transformations in consciousness, from planetary citizens echoing with children's laughter to stellar beings whispering with cosmic winds, fusing into a galactic awareness where all thoughts converge. Perhaps when humanity departs the solar system and galaxy to reach Type 3, all mysteries will unfold. As you sit here now, do you believe humanity can shatter the Type 3 barrier? If you possess the Creator's ultimate power, what would be your first thought? Ponder deeply and share. Humanity's imagination is the key.